once we have an analytical method, we often want to know, will it work not only for our specific use case, but more generally, right? If we have a specific set of procedures to follow, how well does it work? We want to quantify that. We don't just want to say, oh, this is pretty good. We need to be able to say, what are the pros and cons to it, and that is done through method validation. So there are several questions that we need to answer about the method that I've sort of listed here, the general categories of things that we need to answer. The first on the upper left is specificity. So specificity is, do we only measure the thing that we are interested in? Do we only measure our intended analyte? Or will our measurement also measure, is it also sensitive to other things that are present in the sample? And so this will show up a lot when we talk about ion selective electrodes, for example. Maybe something that can measure chloride will also measure bromide or iodide, right? Because they're very similar sorts of ions. Or maybe so maybe that's something you need to know about your method and say, be careful, get rid of these other things before you do your measurement. So this is something that you need to worry about. Or say you're doing a titration, an acid-base titration, which we'll get to do in this class. Your method is not specific, right? It will measure any acid or any base. It's not going to be specific to only one acid or base. And so that's something you need to be aware of for, depending on the use objectives that you have. If your use objective is to measure something that only has one acid or one base in it, then it's great. But if you know there will be multiple acids or bases present in your sample, this is not going to be a good method for it. Okay, linearity. So that's down here. So are you in the linear part of the response curve? And what range of concentrations is linear? So to discuss this further, let's talk about the idea of a response curve. So a response curve is basically the idea that we have a plot. If we take the concentrations or amount of analyte on the x-axis, and our signal, whatever analytical signal we're measuring goes on the y-axis. Ideally this is a straight line, like we've talked about when we talked about least squares fitting. But at some point in pretty much and the specifics of this will depend on what specific thing we're measuring. At some point this will become nonlinear, and it'll start curving. This is usually what happens, is it'll usually flatten out. Maybe you could have something that goes the other way, I don't know. But almost always it's something that the slope increases, and then at some point you just don't get any more signal out of it for various reasons. And so this part, where we have a linear part of our curve here, this is the linear range, and we want the concentrations we plan to measure to be in this linear range. We can't really measure concentrations out here in this range because we don't have a linear response anymore, and we generally assume that there is a linear response curve, right? So we need to make sure that the concentrations we're trying to measure fit in this linear range. And again, this is going to be very dependent on the technique that you're using. So this is something you have to establish about the technique. All right, let's come back up here. Okay, so that's linearity. You want to make sure that the concentrations match the linear response. Okay, accuracy we talked about in the previous video. We want to ensure that our results match the true value. We talked about a couple of ideas: spike recovery, blind samples. Some other things that we can do to ensure accuracy are use some sort of reference material. Have people measure something where it's a known concentration, similar to the idea of a blind sample. Another way to validate a new method is to compare to a different method. So if you, say, have a new way to measure iron in food, you can compare it to the way that's already happening, right? What people are already doing to measure iron in food. Do you get the same results to within statistical uncertainty? We already talked about spikes, and one other way we'll discuss this in towards the end of this chapter is using a standard addition similar to a spike. But we'll discuss that in more detail later in this chapter. Okay. Precision. Again, we've talked about accuracy and precision in the context of a dartboard, right? And remember, precision is reproducibility. Do we get the same results consistently? And we measure this via a standard deviation. So if we do the experiment many times, what's the standard deviation of those measurements? That gives us a sense of how precise our results are. Sometimes you don't need a lot of precision. Sometimes a high standard deviation is okay. If you only need things to be known within, say, a few percent, like something for the label on the back of your food. Whereas if your question is something bigger than 15 parts per billion, you need to be fairly precise with that measurement. And then the final thing is the range. This is related to linearity, but the question here is, what range of concentrations can be measured? And this is something that you have to do measurements on and establish and show what concentrations work with your method. And if you get too high a concentration or too low of a concentration, that you can't actually get a reliable result.